Good morning, my dear students. Welcome to the another session of Anand Medical Academy digital classes. We had discussed two important chapters from your 9th and 10th standard basics till the foundation level NEET and JEE and CET numericals level. What were the two previous chapters we had discussed? Motion in one dimension and gravitation. Why the gravitation chapter is discussed after the motion in one dimension? Because there is a topic in motion in one dimension called a motion under gravity. Here there is a term called gravity. So that's the reason we had started gravitation chapter immediately after motion in one dimension topic. Now, in this motion in one dimension chapter, we had discussed about the kinematic equations. So those are called equations of motion. What are those? Equations of motion. Equations of motion are also called as kinematic equations. Kinematic equations. Okay, see the term called kinematic equations. Now, so keep this in your mind. Then a gravitation chapter. Here, this is our previous chapter. In this chapter, we had started with the difference between gravity and gravitation, then Newton's laws of gravitation and so many numericals related to that, and acceleration due to gravity, where so many factors affecting acceleration due to gravity along with the numericals, and finally Kepler's laws of planetary motion we have discussed. So what are the things we discussed here? Kepler's laws of planetary motion we had learned. Planetary motion we had learned at final. And there are three Kepler's laws we had learned here. Now, what is the chapter we are going to start now? It's the most important part of this session. So the name of the chapter is Force and Laws of Motion. What's the name of the chapter? Force and Laws of Motion. In this chapter, same how we have discussed in motion in one dimension and gravitation, we'll be starting with the basics, which will revise your basics of 9th and 10th standards. Then the middle level numericals and higher level numericals, which are required for your NEET, JEE and CET exams, will be discussed. But again, I'm telling you, this is not the actual concept of first PUC topics, and these are the topics will be very useful for you to start your first PUC with a lot of energy and enthusiasm. Okay, clear? So we'll start the force and laws of motion. First half of the chapter we'll be discussing about force, and rest of the chapter, you can say more than half, we will be discussing the laws of motion. And you can see here force and laws of motion. And there is a connection between this force and laws of motion. What is that connection also we will be discussing now. So this is the part of the session is introduction about the chapter. Introduction about the chapter. Okay, clear? Now let's come back to this chapter called Force and Laws of Motion. I told you just now, keep this term called kinematic in your mind. Okay, so I'm just going to write two terms here. One is kinematics, the another one is dynamics. Kinematics and dynamics. You carefully see the situation here. Kinematics is the branch of physics. It is a branch of physics. kinematics is the branch of physics, whereas your dynamics also the branch of physics. So kinematics is a branch of physics and the dynamics is also the branch of physics. In this kinematics, we will be discussing about, or we will be studying about motion of the body without considering the cause of the motion. So that's an important part here. So without considering the cause of the motion, we will be learning about the motion of the body. Right? See here, kinematics is the branch of physics where we study about motion of the body without considering the cause of the motion. So dynamics is the branch of physics where we study about the motion. Here also we study about the motion of the body by considering the cause of the motion. By considering the cause of the motion. The most important part of the discussion is what is cause of the motion. So here there is a term called cause of the motion. Here also there is a term called cause of the motion. You know what is the cause of the motion? Force is the cause of the motion. For any body to move, there is a force required. So that is the cause of the motion. Okay. Now come back to this kinematics and dynamics. Kinematics is the branch of physics where we study about the motion without considering the cause of the motion. That means without considering the force, the kinematics is the branch of physics where the motion in one dimension belongs to kinematics. In motion in one dimension, except motion under gravity, that comes under gravitation. Okay. In motion in one dimension, could you recollect the motion in one dimension? Can you tell me that in any of the motion in one dimension topics, maybe distance, displacement, speed, velocity, acceleration, retardation, equations of motion, including equations of motion, we have V is equal to U plus AT, S is equal to UT plus half AT square, V square minus U square is equal to 2AS. From this, a special case also we have discussed. Sn is equal to U plus A into N minus half. In all these equations, is there any force is included? Is there any force is included? No, right? Not only in this equation, in all the concepts what we had discussed, including the graphical representation of motion, in motion in one dimension chapter, there is no force is studied or included or in our books. So that's called kinematics is a branch of physics where we study about the motion without considering the cause of the motion. We have studied about the body. How we have studied about the body? So there is an object which is starting from point A and reach to the point B by covering some displacement with initial velocity U and final velocity V. With an acceleration it is moving and time taken to move from here to here is T. Is there any force included here? Is there any force included here? No. We studied about the motion of the body. We studied about the displacement, means motion of the body. We studied about the change in velocity in time, that's called acceleration, without considering the cause of the motion. But the body is moving means there must be some forces required, right? That force we have not studied in kinematics. Only we have taken from here to here without considering the force. Now, in the force and laws of motion chapter, we study about the force, which is the cause of the motion, along with this motion of the body plus force. Understand? Motion of the body we study plus force. That's called dynamics. Dynamics is the branch of physics where we study about the motion by considering the cause of the motion. By considering what? Cause of the motion. Okay. Now, let's see the force first. Force. As the name force. It is the vector quantity. Force is a vector quantity because it has magnitude as well as direction, right? And the SI unit of the force is Newton. SI unit is Newton, denoted with the symbol capital N, right? You know, CGS unit of the CGS unit is dyne. Okay. Now, 1 Newton is equal to, I am writing here, 1 Newton is equal to 1 kg meter per second square, and 1 Newton is equal to 10 raised to 5 dyne. Remember, 10 raised to 5 dyne. Okay. And 1 Newton is 1 kg meter per second square, right? This is SI unit. CGS unit, I told you, 1 dyne, which is equal to, this kg will be written in terms of grams, because CGS unit mass will be represented with grams. So 1 gram, so meter is represented in centimeters, and per second square is second square only, right? 1 Newton is 1 kg meter per second square, 1 dyne is 1 gram centimeter per second square. So from both these two expressions, I can write 1 Newton is equal to 10 raised to 5 dyne. Okay. And for your better understanding, I am telling you here, this force is equal to mass into acceleration. Okay. In your lower class, this is not the first time you are learning about a force. So many classes, like starting from 6th standard or 5th standard, you will be listening to the term called force, force, force. So that force is equal to mass into acceleration. That's what I have written here. Force unit is Newton, mass unit is kilogram, and acceleration unit is meter per second square. Okay. Mass CGS unit is gram, and meter CGS unit is centimeter, second square CGS unit is second square. Okay. So this is what the basic introduction about the chapter. Now we will be discussing about the force first, then the laws of motion. Right? And before moving into the chapter, laws of motion. Newton's laws of motion. Newton's first law of motion, second law of motion, and third law of motion. Kepler's laws of planetary motion. Kepler's first law, second law, third law. This is exclusive concept about the planetary motion, but not any other body's motion in the nature. But Newton's laws of motion can be applied to any body in the nature. Alright? So we will be discussing about force and laws of motion from now. Let's continue the chapter, force and laws of motion. What we had just now discussed, this is the force which is a push or pull acting on any body. That's called the force. And this is the force is a vector quantity which will have both direction and magnitude. Clear? And this is the force. SI unit is Newton. 1 Newton is 1 kg meter per second square. 1 dyne is equal to 1 gram centimeter per second square. And both together there is a relation. 1 Newton is equal to 10 raised to 5 dyne. And there are force what it can do. There are some points what the force can do. One by one we will be discussing. So these are the basics, what we have already discussed, what you might have learned in your lower classes. We are starting from basics. So then medium level, then we move to the higher level, right? First one. The force, what it can do. Number one, the force can change the state of a body. the state of a body. The force can change the state of a body. We have two states of a body, the possible two states of a body. Number one, the body may be in the state of rest. Number two, the body may be in the state of motion. That's it. So the body may be in the state of rest or in the state of motion. So the same thing I will write here. So the states of a body, number one, the body may be in the state of rest or may be in the state of motion. For example, when the body is in the state of rest, by applying force, you can make the body in the state of motion. Already the body in the state of motion. By applying force, you can make the body to come to the state of rest. Alright? So many examples are there. Imagine there is a ball which is at rest. By applying your kicking force, the body will change its state from state of rest to the state of motion. Imagine you're moving in a car already in the state of motion. By applying braking force, you can bring the body to the rest. So that's called the force can change the state of a body. And number two, the force can change the speed of a body. The force can change the speed of a body. Imagine you are moving in a bicycle. Look at here. So this is the ground. Imagine you are moving in a bicycle in this direction. This is the motion of yours in a bicycle. Your friend is pushing your bicycle in this direction. So that means in the direction of the motion, he is pushing your bicycle. So what I can say, the speed of the bicycle increases, yes or no? Definitely it is yes. Imagine you and your friend had a great fight between you. He's so angry at you. You are moving in this direction, but your friend is pulling you in the opposite direction. So that is what the force he applied in the second case. Then what happens? So when your motion and the force in the opposite direction, so the speed of the body will decrease. See here, the force which is having direction, that's the reason we wrote it's a vector quantity. According to the direction of the force, it can change the speed of a body, right? So the same example we can also write, for example, so this is the ground, a body is dropped from here, so the body is moving in this direction. This is the motion direction and the gravitational force will be acting in the same direction. When the force and motion are in the same direction, so the body will be speeds up. Okay, clear? Opposite is also true. It will slows down when you throw the body. So the body motion is in one direction and the gravitational force always towards the center of the earth downwards. Motion is in the upward direction, force is in downward direction. That means they are in opposite direction. Then the speed of the body will obviously slows down. Okay, so that's what the force can change the speed of a body. This is also true. And number three, the force can change the direction of a body. The force can change the direction of a body, right? So direction of a body. So imagine you are playing football or a cricket match, whatever it may be. So when the ball comes in one direction, so by using your hitting force, the direction of the ball will be changing. Even in the football also. When ball is moving or coming to you in one direction, after applying kicking force, the direction of the ball will be changes. So that's called the force can change the direction of a body. Alright? Now, number four. The force can change the shape and the size of a body. The shape and size of a body. Right? So imagine we have a sponge which is kept in our hand. By applying force, a crushing force here, the size and shape of the sponge will be changed. Yes or no? Definitely it says. So these are all the things the force can do. Right? Now, look at the interesting part here. So about three things we are going to discuss related to the force after the concept called force, what it can do. About three important things. And number one, about the concept called resultant force. What is it called? Resultant force. And the second one is called balanced forces. Balanced forces. And the third one is called unbalanced forces. Balanced forces and unbalanced forces. So these are the things we are going to discuss now. Alright. So what is the resultant force? First we will be discussing now. So let's continue the topic called force. In that force, the first concept I had told you, we will be learning about resultant force. Resultant force is the total force acting on a body according to the direction of forces. So that's called resultant force. The total force can also be written as a net force. What is meant by the net force? Look at here. Imagine this is the ground. There is a body here. One force is acting on it, which is called F1 in this direction. The another force acting on it in this direction, that is F2. You know, the resultant force is denoted with the symbol F suffix RES. So this resultant force in this direction will be equal to, as both the forces are in the same direction, I told you here, the total force acting on a body according to the direction of the forces. As two forces are in the same direction, I can write it as F1 plus F2. We just need to add them up. For example, this is the ground, two forces acting on the body in this direction. It is F1 and it is F2. And they have clearly mentioned that F1 is greater than F2. So if this is 100 newtons, so this may be less than 100. Okay. So in this case, the resultant force can be identified by using the difference between the two forces, F1 minus F2. So that's called the resultant force. What is this called? Resultant force. The net force acting on a body is called the resultant force. Okay. Now, this is the body will be moving with what amount of force? Total force, F1 plus F2. So this body will be moving with what amount of net force? F1 minus F2. So for example, this is 20 newtons and this is 30 newton. Newton is SI unit of force. Now, if the force, net force, if we want to find out here, that will be 20 plus 30, 50 newtons. Right? Now, if this F1 is 70 newtons, this F2 is 20 newtons, and the resultant force here will be 70 minus 20, which is 50 newtons here. Okay? Clear? So when there is a force and the body will be accelerating, we know, I have told you already, as F is equal to ma is the equation you might have studied in the lower classes. When there is a force and mass, anyhow it is constant and the body will be accelerated. When there is a force, the body will be accelerated. This is the force called accelerating force, and this is the force called accelerating force. Okay? Clear? So what I can say, when there is a force which is not equal to 0, so I can write here, when the forces which are not equal to 0, and these are the forces called unbalanced forces. What are those forces called? Unbalanced forces. Clear? Because force can accelerate. So these are the unbalanced forces can accelerate the body. Can what? Can accelerate the body. Accelerate the body means they can change the speed of the body. Okay. Now, next case. See a very important case here I am going to tell you here. So there is a force of 100 Newton acting in this direction, and there is a force of 100 Newtons acting in this direction. Or you can say 90 Newton is acting in this direction and another 10 Newton is acting in this direction itself. Carefully see. The total force acting in this direction is 100 Newton. Total force acting in this direction is also 100 Newtons. As 100 Newtons this direction and 100 Newtons this direction, so I can say the net force or the resultant force is 0 Newtons. Are you understanding? The net force acting on a body is how much now? 0 Newtons. 0 Newtons means, so when net force is 0 Newtons, mass into acceleration is also 0, and from here acceleration is equal to 0 meter per second square. And carefully see. When acceleration is 0, the body can exist in two states. Right? Look at here. Acceleration is 0, the body may be at rest. What is the acceleration of a body which is at rest? 0. Or the body may be moving with constant speed. Right? Acceleration is 0 means what? Constant speed. So what I am going to tell you is, when net force acting on a body is 0, it can have two states. When resultant force acting on a body is 0, it can have two states. The body may be in the state of rest, or the body may be in the state of uniform motion. So both are possible. Uniform motion means what? Constant speed. Constant speed means acceleration is 0. So very, very important point is this one. Right? Now, net force is 0. So then these are the forces called balanced forces. Under the action of balanced forces, the body may be at rest or the body may be moving with uniform motion. Right? And these balanced forces cannot accelerate the body. The balanced forces cannot accelerate the body. Okay. The balanced forces cannot accelerate the body, but unbalanced forces only can accelerate the body. Because to accelerate, there must be a force. But in balanced forces, so the net force is 0. Understand? So the body cannot accelerate. Understand? So these are the cases of balanced forces and unbalanced forces. Now, the most important difference between balanced forces and unbalanced forces we are going to learn now. And before moving to that, and let's see some examples of resultant force. So this is 10 Newtons and this is 20 Newtons. Okay. So this is 50 Newtons and this is 5 Newtons. And carefully see the situation here. What is the net force acting on a body? We need to find out. And it is so simple. According to directions, when two forces are in the same direction, we just add up. When two forces are in opposite direction, we just subtract. And this 10 Newton and 5 Newton are in the same direction. I can say 15 Newton is acting in this direction. So overall what I can say, so 15 Newton is acting in this direction and the other direction 50 plus 20. So this is what 17 Newton is acting in this direction. So when this force and this force are in opposite direction, so the difference is 17 minus 15. 70 minus 15 is how much here? So it is 55 Newton. 55 Newton is the resultant force. But force is a vector quantity. This resultant force also is a vector quantity which you have direction. As individual forces directions are mentioned, you need to mention the resultant force direction also. Okay? Always the resultant force will be directed in the direction of larger force, right? So what is a large direction? Large force, 70 Newton, right? So the net force will be in this direction. Okay, clear? And you may have doubt, you may got the doubt. So these all the forces are acting in the horizontal direction. What about the vertical direction? Right? So that also I will tell you now. Look at here. So this is the body. Downwards there is 50 Newton's force is acting, and upwards there is 10 Newton's force is acting. Here also the same thing, as forces are in the opposite direction. So the net force will be equal to 40 Newtons. You may get another doubt. All these forces are horizontal and vertical. If the forces are inclined, how to do that? Imagine this is the body we have, right? These are the two forces, and the third force is acting like this. So it is 70 Newton's force is acting like this. In this case, how to find the net force acting on a body? So that is your first PUC topic. Okay, but we are not going to discuss now, because to solve this kind of numericals, you need a concept called vector resolution. What is that? Vector resolution. The vector resolution you will understand by knowing the concept of vectors first, right? So when our actual classes starts, maybe in online or offline, as early as possible, we will be discussing about vectors concept also. There, vector resolution will be the topic. You will understand, then you will understand. So this kind of problems also to solve. So till now, just keep revising the topics which are the basics for your 11th standard and 12th standard. Just the forces are horizontal and vertical. That's it. Don't do the silly kind of mistakes. Now, the topic is the differences between or the similarities between balanced forces and unbalanced forces. We will be discussing right now. Let us understand the final topic of the session. Differences and similarities between balanced and unbalanced forces. Balanced forces, unbalanced forces. It's so simple. Balanced forces we have already discussed. In balanced forces, the resultant force is 0. Under the action of balanced forces, the resultant force is 0. When resultant force is 0, so the body may be at rest or the body may be in the state of motion. Unbalanced forces. Under the action of unbalanced forces, so the resultant force is not equal to 0, and definitely the body is in the state of motion. And these balanced forces cannot change the state of a body. When the body is in the state of rest, under the action of balanced forces, it will be in the state of rest. When the body, this is uniform motion. When the body is in the state of uniform motion, because force is 0, acceleration is 0, body is moving with constant speed means uniform motion. So, when the body is in the uniform motion, under the action of balanced forces, it will be in the state of uniform motion. When the body is at rest, under the action of balanced forces, it will be in the state of rest. That means it cannot change the state of a body. The balanced forces cannot change the state of a body. But the unbalanced forces can change state of a body. Can change. By what? By the application of unbalanced forces. Right? So here the third point, so the balanced forces cannot change the speed of a body, but unbalanced forces can change the speed of a body. Right? And balanced forces cannot change the direction of the body, whereas unbalanced forces can change the direction of the body. You can carefully see everything can change can change, can change. Unbalanced forces can do everything, right? And the last important point I'm writing in unbalanced forces. Here, unbalanced forces can change the shape and size of the body. Size and shape of the body. But, look at here. Here everything cannot change, cannot change, cannot change. But balanced forces can change the shape and size of the body, right? Carefully see, balanced forces only can change the shape and size of the body. Unbalanced forces can change size and shape, can change direction, can change the speed, can change the state of a body. But balanced forces can only do one thing, which is they can change the shape and size of a body, right? Now listen to me carefully. Imagine we have a sponge. In the last part of the session I have told you. Imagine you have kept a sponge in your hand and applied a crushing force like this here. Crushing force. What happens? The shape and size of the body is changed by the application of force, but the body is in the same state of rest. Yes or no? As soon as you apply a crushing force, the body is not flying. Yes or no? The body is not at all flying. It will be in the same state of rest. So that's the concept called the balanced forces I am applying, but the shape and size of the body is changed, but not the state of a body. Clear? So balanced forces can only change the shape and size of the body, but unbalanced forces can do everything. They can change the state of a body, they can change the speed of a body, they can change the direction of a body, they can change the size and shape of a body. And the last point about the differences is, so these are the differences, 1, 2, 3, 4, 1, 2, 3, 4, and the similarity is only one. Balanced forces can change the shape and size, unbalanced forces also can change the shape and size of a body. Okay, clear? And see you in the next session.